This video provides a concise overview of the hydraulic seeding method used in highway construction projects, including its advantages and disadvantages, guidelines, and the importance of inspection and execution for successful vegetation establishment. What is the hydraulic seeding method? Hydraulic seeding, also known as hydroseeding, is a seeding process that combines water, seed, organic fertilizer, and amendments into a slurry that is sprayed uniformly from a truck-mounted tank over the areas to be seeded. The pressurized slurry helps to broadcast the seed evenly across the area being seeded and helps to work the seed into the soil if it is left in a tilled condition. For germination, it is important for seed to have soil contact. The audience for this video includes stormwater management plan designers and reviewers, region permanent stabilization subject matter experts, CDOT engineers, and project engineers and their designees. Refer to CDOT Specifications Section 207 and 212 and Design and Construction Bulletins before conducting hydraulic seeding. Instruction and guidelines for Specification 207 and 212 include specific details for subsoil and topsoil preparation, organic fertilizers, soil amendments, seeding methods, and checklists for inspectors. Before starting with application, refer to the contract for quantities of organic fertilizer and soil amendments. Seed should match the species and rates shown on plans. A seed tag calculation worksheet and seed and amendment quantities checklist is available on the Landscape Architecture website. Hydraulic seeding equipment is attached to a truck and is composed of a tank, pump, nozzle, and hose. For example, hydroseeding can be used on flat to steep slopes and is best suited when drill seeding is not practical. Hydraulic seeding should be specified for projects 1/2 acre or greater due to the higher costs of mobilization. Hydraulic seeding can cover large areas quickly and areas that a drill seeder cannot access. Hydroseeders are able to spray to distances of approximately 200 feet or more, allowing for the ability to seed steep slopes, roadside cuts, rocky terrain, or areas inaccessible to drill seeding equipment. Hydraulic seeding is followed up by final stabilization methods including hydromulching, bonded fiber matrix, or use of erosion control blankets. It is important to note that hydromulching is not conducted with hydroseeding. They are conducted in two separate applications. Although drill seeding is CDOT's preferred method of seeding, hydraulic seeding can offer several advantages for a highway construction project, including, like use on steep or difficult-to-access terrain. Hydraulic seeding can be used for hard-to-access areas, challenging terrain, and steep and rough slopes such as mountainous areas. Versatility for use on a variety of soil types such as rocky soils. Cost-effective for larger projects where soils or site conditions are not suitable for drill seeding. In addition, fertilizer and soil amendments can be added to the slurry so everything is applied at once, saving time. It is important to note that while hydraulic seeding can offer many advantages for a highway construction project, it may not be the best option for every project. The specific requirements and constraints of each project should be taken into account when deciding whether or not to use this method of planting. The potential disadvantages of hydraulic seeding can be mitigated with proper planning and execution. Like limited seed-to-soil contact. Hydraulic seeding is not as effective as ensuring seed-to-soil contact as drill seeding. The limited seed-to-soil contact can affect seed germination and growth in periods of drought. If not done correctly due to poor soil preparation and lack of crevices in the topsoil structure, using correct nozzles and pressure can result in compacted soils, erosion, and poor germination due to poor seed-to-soil contact. A disadvantage of hydraulic seeding is it requires water for application. This can be a disadvantage in remote areas where water needs to be trucked in from an approved source. Another disadvantage is seed washout. If the site is exposed to heavy rain or runoff prior to final mulching or blanketing, the seed can be washed away. Depending on weather conditions, the seed process may be delayed if the weather is not suitable for seeding. It cannot be applied in high winds. It's important to note that although there are some disadvantages, these can be mitigated with proper planning, equipment, and execution of the project. Construction phase. Hydraulic seeding inspection and verification. Whether you are a reviewer or inspector, review the contractor's method statement, baseline schedule, and milestones for timing, equipment, and quantities of seed and amendment and their storage needs. Application of organic fertilizer, soil amendments, and seeding should be milestones in the baseline schedule. Review the contractor's method statement, baseline schedule, and milestones. After topsoil placement, seeding and final stabilization activities must occur within 4 days. Mulching or blanketing must occur within 24 hours of hydraulic seeding. Seeding should be conducted within the seeding seasons in the 212 specification. Hydraulic seeding is not recommended when extended periods of hot and dry weather are expected. Seed should match the species and rates shown on plans. If there are substitutions due to availability with suppliers, work with your region's permanent stabilization subject matter expert for approval. Monitoring the seed and amendment storage on site, reviewing packing slip of seed and record keeping of correspondence, submittals, and resubmittals. Conduct a site inspection. The seed beds should be free of stones and other debris greater than 4 inches in diameter. The topsoil surface should be prepared with a surface variation of 2 to 4 inches. Do not work in frozen or wet soils or during periods of high winds. Review the vendor's packing slip of seed. Confirm the seed has not been in possession of the contractor for greater than 30 days. Reject seed bags over 30 days old. The packing slip needs to include a copy of the purity and germination report dated within 13 months of date of seeding. Proper storage of seed and amendments. Seed and amendments are to be stored out of direct sunlight, surface water, and precipitation, and not in temperatures over 80 degrees that can destroy biotic life in the amendments or reduce the germination of seed. Reject wet, moldy, or damaged seed and amendment bags. Maintain seed tags, submittals, and correspondence. Work with region permit stabilization subject matter experts to help verify seed mix and rate, approve submittals, and answer any questions that may arise during construction. Overall, the inspection and verification of hydraulic seeding method is crucial for ensuring that the equipment and materials used for the seeding are in good working order, that the seeding method is being performed correctly, and that the seed and amendments are being applied at the correct rate. Maintain proper topsoil surface conditions per Section 207. The seed bed or topsoil surface should be left in an uneven condition, with a surface variation of 2 to 4 inches. This helps prevent erosion, but also creates various microclimates to help with germination. The timing of seeding is crucial to the establishment of desired vegetation. It is important to seed during the seeding seasons in Section 212. Seeding rates should be specified in the plans. If drill seeding was specified in the contract and hydraulic seeding method is substituted, the seed rate should be increased by 1.5 times the drill seed rate. With seeding, more is not better. Overseeding or adding too much seed results in a vigorous initial establishment, but in the long term, there will be less vegetation due to the seedlings competing for sun, air, nutrients, and water resources. The hydraulic seed slurry is applied in 2 directions to obtain 100% coverage of the soil surface and to reduce the shadowing or uneven application created by just one pass. The contractor is to apply the slurry at a range and with a nozzle that avoids the slurry splashing off the surface and causing soil to dislodge. The slurry should be mixed for half hour prior to application and throughout the application process. A 2-pass method provides good seed coverage. In the first pass, 50% or less of the slurry is applied, followed by the second pass from the opposing direction that applies the remainder of the slurry. Too little of the seed slurry or under-application of seed can lead to increased weed establishment and surface erosion where exposed surface soil is present due to lack of vegetation establishment. Too much application can lead to too much seed that compete for sun, air, and nutrients. What does the engineer inspect and verify? Inspect the seeded area after the seeding process is complete to verify that the seed slurry has been distributed evenly and that the soil is compacted properly. No hydromulching combination. It is important to note that per Section 212, hydroseeding and hydromulching are not completed at the same time. Seed applied at the same time as hydromulching will not successfully germinate if suspended in the mulch with no seed to soil contact. Thank you for watching. please watch our next video.